Lit, Logic, Ideas, Thoughts, and Theories by Mike Secco. Now, you've heard the term, it's not rocket science. Well, today's lit feature is rocket science, so we're going to talk about launching of rockets into space. And as most of you already know, in order to launch something out of the Earth's gravitational field, that's called the escape velocity, you have to reach a speed of about around 17,000 miles per hour. So we're going to talk about that in just a bit here. Thank you. Okay, today I want to talk about launching rocket ships. Now, a rocket ship, as you know, has, and let me change slides here. And this particular one is Saturn V. It's probably the biggest rocket ever made. You can see each one of the 5 engines is bigger in diameter than I think it's like 6 or 7 feet in diameter. Okay, now this huge rocket, when we talk about launching a rocket this size, and excuse, I am not using a tripod, so it's a little shaky here. We're talking about this big rocket launching a payload that goes, I'm going to use my pen here, from here to here. Everything else is hardware and fuel to get this thing into space. And we're going to talk about cheating a little bit. And we're going to take the example of the pole vaulter. Now, if you had a pole vault, and if you just stood there on the ground and tried to pole vault, you wouldn't go very high at all. But yet you get a big run and build up a little speed, and then you convert that lateral speed into vertical speed and vertical lift. And that's exactly what a pole vaulter does. Well, we're going to cheat a little bit on our rocket launch today, so that's what we're going to do. Okay, today's idea is really very simple. Breaking inertia is something that takes a tremendous amount of fuel to do, and especially when you have all that weight. So what we're going to do is we're going to put a rocket on the top of a hill on a sled that's on a rail. And basically what we're going to do is kick out the chocks, let that rocket roll down that hill, and when it gets down to the flat bottom here, we're going to have right in through here, and this could be miles and miles long. We're going to have a linear motor, and I'll show you how that works in just a second. And then once we get it up to speed, and I'm saying up to speed, I'm saying at least Mach 1, maybe faster, then we're going to turn it up. And when it gets right around here, we're going to light the rockets and set her on our own and let her go. Okay, so I'm going to turn the page here. So okay, here we have the rocket sitting on the sled, and what we have here is huge electromagnets, and they're going to pull. They're going to be pulling, the one magnet's going to try to pull to the other, like so, like my hands are moving there. And once they get close, this magnet will release, and the next magnet in line will start to pull. And you'll have thousands of these magnets just pulling this along, accelerating. This is a linear motor. And what we have here is a track, and these are all the magnets. And you just keep moving, building up speed until you get to the end of that track, and then we'll turn it up on end. So that's how a linear motor works. So there you have my thoughts for today. So basically, instead of taking tons and tons of fuel just to get this thing moving, this huge tons of rocket fuel and engine and payload, instead of using all that fuel to lift the fuel, all we're doing is kicking out the chocks from under the wheels and letting gravity get the thing started. Once it's moving, we start accelerating it on the lower part with your linear motor and driving that thing till it's going faster and faster and faster. Then we're going to turn up on end and let her go, and then we start our rockets, and we have it moving toward the sky, and it takes a whole lot. Once it's moving, it takes a whole lot less power to accelerate it. And as we burn more fuel, of course, it gets lighter and lighter, and less is needed to accelerate it even more so. So anyway, that's my thoughts for today. Let me know what you think. If you think it's ridiculous, let me know. If you think it's a good idea, let me know that. You can see my email address below is mikeseko@email.com. And thanks for listening to my idea for today, and hope you enjoy it. And there's more to follow, and check out some of the other ones that's already posted. LITT. Logic, Ideas, Thoughts, and Theories.